Okay. Today's topic is robot localization, and under this localization, we will be discussing two type of methods. So, map-based and behavior-based. So now here in the diagram shown, the robot has to move from point A to point B. So some type of activity is planned, or some type of message it has to deliver. Okay, from for that it has to move between these 2 points. Now here two type of approaches are there. So in the localization may seem mandatory in order to successfully navigate between the two rooms. Okay, room A and room B. So it is through localizing on a map, after all, that the robot can hope to recover its position and detect when it has arrived the goal position. So A, that is the room A, inside there that is the initial position, and the robot has to move to the goal position that is in the room B. So it is true that at least the robot must have a way of detecting the goal position. So however, explicit localization with reference to a map is not the only strategy that qualifies as a goal detector. So here one type of technology or the method used, that is the map based. So map is there and the robot is following that map. Okay, the another alternative method, that is a behavior based uh, method, and it suggests that since sensors and effectors are noisy, so the issues with the sensors we have discussed in our previous the topic. So the okay, so need not go in detail with that. Okay, then it is available here in the playlist. Okay, so the one should avoid creating a geometric map for localization. Okay, so map building that is not encouraged by the behavior-based community. So instead, this community suggests designing set of behaviors that together results in the desired robot motion. So fundamentally, this approach avoids explicit reasoning about localization and position, and thus generally avoids explicit path planning as well. So this one that is simpler as compared with the map building. In the first method, the map based, the robot has to move from initial to the goal position, and it has to develop a map, and then it has to follow the map. Okay, on the other hand, the behavior based community that delivers other method, that in the we can plan the path, put some marks there, and the robot can identify that mark and take the type of action which is needed. So here in the diagram, both type of the techniques, they are shown here. In the upper diagram, the sensors, they are providing the data, and that is for the behavior based navigation. So the communication of the data: discover new area, detect goal position, avoid obstacles, follow right or left wall. Okay, so like we can follow, we can consider in that case of point moving from point A to B. So the robot has to follow the wall. So like the right wall, it has to follow. Okay, the robot that will sense and that will follow the right wall. Okay, through that it can identify where it is going, where there are some obstruction. The sensor can give the data for that. Okay, finally it will reach the a goal. Okay, or also we can put some type of mark there on the wall of the room number B, and as the robot comes across that mark, it will identify that it has reached the room number B. Because here map is not built, it has to only follow some type of pattern, or the wall, like the left wall it has to follow, or the right wall it has to follow. So this technique doesn't include building some type of map. So so the complexity level, that is also less in this case. Okay, then the coordination or the fusion. So all of this data that is fused, and it is sent to the actuators to take the required action. Okay, in the lower diagram there, that is for the map based navigation. So sensors, they are the giving the input, the data, then perception, or then the map building. So through that map, the robot is moving. Okay, so the planning, then motion control, then further last to the actuators. So in contrast to the behavior based approach, the map based approach includes both localization and cognition modules. So in map-based navigation, the robot explicitly attempts to localize by collecting sensor data, then updating some belief about its position with respect to a map of the environment. So these are the difference between both of these methods. Okay, so the key advantage of the map-based approach for navigation are, so the first advantage, the explicit map-based content of the position makes the systems believe about position transparently available to the human operators. So this is the advantage, that the position is available there to the human operator. The next advantage, the existence of map itself presents a medium for communication between human and robot. Okay, so the communication is there, man and the machine. So the human can simply give the robot a new map if the robot goes to the new environment. Then further, the map, if created by the robot, can be used by human as well. So achieving two use means the robot has built up the map in its memory, then it is following that map of reaching to the goal position, and that map can be used by the human being as well, or the operator as well. So map-based approach will require more upfront development effort to create a navigating mobile robot. Yes, so the map-based approach requires more upfront development. The hope is that the development effort results in an architecture that can successfully map and navigate a variety of environments, thereby reducing gradually the upfront design cost over time. Okay, so it is being expected to reduce the cost also over the time. So the key risk of the map-based approach. So here we are discussing the disadvantage is that an internal representation, okay, rather than the real world itself, is being constructed and trusted by the robot. Yes, because this is the internally the robot has built up the map in its memory, or we have provided the map, the operator has provided the map, so that is what the robot is trusting. It is not trusting the external environment. Okay, so if that model diverges from reality, okay, maybe if there is some error in the map, something goes wrong in the map, then the robot's behavior may be undesirable because it is following the map only, blindly it is following the map. So even if the robot sensors values, even if the raw sensor values of robot are only transiently incorrect,